Hi guys, welcome back to another episode of Last Minute A. Actually, I should be saying welcome back to the first episode of 2026 of Last Minute A. This is the channel that helps you with all your problems related to life sciences. It's either the night before your exam or you're starting a new section in your life sciences and you're a little bit scared. This channel is like a painkiller to everything that you need to know about life sciences. So sit down, grab your notebooks, and stay tuned. And before we get started, I just want to say that congratulations to the class of 2025. I am so proud of you guys, and I hope you are also proud of yourselves. And I hope this new chapter of your life is filled with a lot of opportunities that you're going to grab hold of and run with. And I just wanted to say that this year the channel is a little bit different. There's a lot of new things that are coming up. So this year we're going to be doing sections for grade 10, 11 and 12. So you heard that right. New year, new me. We are coming in different, and I hope that you enjoy all the content that I'll be giving to you guys this year. But before I ramble too much, you will be seeing the changes as I keep posting. So this year we are going to be starting off with grade 10. This video specifically is going to be for grade 10. I'm sure you're going to see that on the title. We are going to be looking at the scientific method today. So we'll be explaining what is the scientific method, describing and identifying the steps of the scientific method, differentiating between independent and dependent and controlled variables, and how you represent your findings. I'm sure you're wondering, what is the scientific method anyways? Let me explain. A scientific method is a step-by-step process used in science to answer questions and test ideas. Basically, it is the method that you use to conduct your experiment. Even from just thinking of your experiment and that idea that you come up with, whatever you're curious about, you have to follow this method in order for you to find the answer to your curiosity. So let's look at the steps that you have to follow in this scientific method to be able to test your ideas and find your answers to your questions. So firstly, obviously, you have the problem, your question. How does this thing work? How do I solve this? You do your research basically on what you know about the things that you want to test or the things that you're curious about. Then you come up with an hypothesis, and then you conduct your experiment. You check and you identify your variables, and then you collect and you record the data that you observe while conducting your experiment. That helps you then come up with the conclusion. So let's start from the top. Let's conduct our own experiment. So you're curious, you want to know, does sugar dissolve faster in hot water? You're just curious, you want to find out if sugar dissolves faster in hot water. That is the question. That is what you are curious about. So you have your question now, you have your problem. Now you have to come up with your hypothesis. And in order for you to come up with your hypothesis, you have to do your research. Think about what you already know with what you have. Sugar. Okay. What do you know about hot water? Hot water obviously makes things melt, but not really cold water. So you can now be able to come up with the hypothesis with just that knowledge on itself. So now you're like, okay, what is this hypothesis? Well, a hypothesis is a statement. It is an educated prediction. You create this statement based on some things that you know through research, and you take an educated guess. And for this experiment, we are guessing that the water is going to dissolve faster in hot water. So if the water is hotter, the sugar will dissolve faster. That is our hypothesis. So it's a statement. You are saying this as if it's a fact. If water is hotter, then the sugar will dissolve faster. That is your hypothesis. Now you're getting into your experiment. So now you are identifying your variables. So you want to know what are you going to be paying attention to while you're conducting this experiment? What is the changes that you need to expect, or which variable is going to be changing? So this is where your variables comes in. Which are your variables? We have the independent variable, which is what's going to change, and then you have the dependent variable, which is what you are going to measure, and then you have the controlled variable, which remains the same the entire time we're conducting this experiment. So in this experiment that we are doing, our independent variable is temperature, and temperature is what you're going to be changing in order for you to find out what's happening. And why is temperature the independent variable? So we're gonna have boiling water, which would be at probably 100 degrees Celsius, and then we'll have cold water, which maybe might be low to maybe -1 degrees Celsius, and then we have maybe normal room temperature water, maybe it's like 36 degrees Celsius, and then you have room temperature water, cold water, and very boiling water. So those are the variables. That's the independent variable. You are going to be changing this variable to see if there will be any change to your dependent variable, and this will be the time taken to dissolve. You want to find out if you change the temperature, will your sugar dissolve faster? That means you are measuring the time to see how fast it takes for your sugar to dissolve. So that's what you'll be measuring as you change the temperatures. And then your controlled variable will be the amount of sugar. You have to have the same amount of sugar because that obviously affects your experiment. You have to have the same amount of water, the same type of sugar. Is it a brown or white sugar? And it's either you have it in like blocks or granules, and also you have to also be stirring. So you're going to be using the same method in each time you're testing for different temperatures. You'll be stirring instead of maybe on the other experiment in a different temperature. You'll just let the sugar dissolve itself, and then in the next temperature you'll then be stirring. You shouldn't be doing that. So now we have identified our variables. Now we can move on to the next step. Now the next step in this scientific method is figuring out what you're going to need for your experiment, and that's where your apparatus comes into place. So your apparatus are the equipment you're going to need. So this is a list of the tools and the materials that is used in the experiment. So you have to figure out what you're going to need. So for this experiment, we're going to need 3 identical cups or beakers. We need hot water, we need room temperature water, and we need cold water. It's either we're going to refrigerate the water or add ice cubes in the water. And then we're just going to make up the amounts here. We're going to need 3 teaspoons of sugar, a stopwatch or a phone timer because we'll be measuring the time, something to stir with, either a spoon or a rod, and a thermometer, obviously, to measure our temperatures, make sure we know which temperature the waters we're in so that we can make sure we got all the details on T. Now, how are we going to conduct this experiment? That's where your method or procedure or steps come in. So now you're going into the method. So this is now you conducting this experiment physically, okay? So step 1, you label your cups or your beakers so you know which is which. You have the cold water cup, the room temperature cup, and the hot water cup. And then you have to pour an equal amount of water into each cup. For example, we're going to say 100 milliliter. Measure 1 teaspoon of sugar for each cup. And then you're going to measure 3 teaspoons of sugar for each cup. Then you're going to place the sugar into each cup one at a time. Then you're going to start your stopwatch. As soon as the sugar is added, you start the stopwatch. So in this situation, this means you're going to take 1 cup you put the sugar, you start the stopwatch, you start measuring and seeing how long it's going to take for it to be completely dissolved. You do that again with the next cup, you do that again with another cup. And every time you stir each cup at the same speed for consistency, okay? Then every time you finished working with each cup, you record how long it took to completely dissolve the sugar. And if you feel like you want to make sure your experiment is very accurate, then you repeat the test. Okay, you can repeat it all over again. And all the findings, the time taken and all of that, you write those results down in a table so that you can see the difference for each cup. So now, since we've went through the method, we have physically conducted our experiment, and now we are done. Now, what you have to do after you have physically conducted your experiment is now look at your results and analyze them. So now you're at the analysis stage. So in this stage, you're supposed to look at your results and interpret them, explain what your results mean using the data that you have been recording. So for example, since you recorded everything for this experiment that we just did, and this is the analysis that you come up with, this is an example. So you might say that the results show that sugar dissolved faster in hot water, slower in room temperature water, and slowest in cold water. This means temperature affects dissolving speed. The higher the temperature, the faster the sugar dissolves. So this is what you interpreted. You look at your table, you saw that this is, maybe it was in seconds, this is the seconds that it took for cold water, this is the seconds that it took for hot water, maybe it was seconds for hot water and almost a minutes for cold water. So you look at that trend and you're like, oh, okay, this is what this means. That's what it means to analyze your results and the data that you have been recording. And now obviously with what you have analyzed, you have to come up with the conclusion. Okay, so during the conclusion phase, this is where you summarize your findings and findings based on the hypothesis and results. So now you're summarizing the whole thing, what you find out and what does this mean based on the question that you had initially and the educated guess that you made. So you made this guess and you were testing out the guess, and we said that the hotter the water, the faster the sugar will dissolve. That's what we had guessed, and we were testing that if it is true that if the water is hot, then your sugar will dissolve faster. So we're looking at that guess, which was our hypothesis, and the result. What are we seeing? That's what you do in your conclusion. So this is our conclusion. The hypothesis was supported, was correct. Sugar dissolved faster in hot water than in cold or room temperature water. Therefore, increasing temperature increases the dissolving rate of sugar in water. Here we go. You have done your experiment. You have looked at your data. You have figured out your curiosity and figured out the answer to your question. So I hope this was nice and clear. So let's look at other things now that also affect the scientific method. You're done with your experiment. You saw the results. You're proud of your experiment. But now you just want to evaluate your experiment. This is very important in the scientific method. Evaluating basically means you are reflecting on the experiments and the answers that you got, the results that you got. So these are the questions you'll be asking yourself once you're done with your experiment. So you look at the data, you look at your conclusion, and you have to take your time and think about everything. Look everything from the way you conducted your experiment to the variables, the equipment you use, every single thing. And you sit down and you ask yourself these questions. Was the experiment fair? Was it fair? Did I make sure that I treated every single cup with the different temperatures same? And in this experiment, we can say that the experiment was mostly fair because we kept the amount of water and sugar the same. So this is how you make sure your experiment is fair. You made sure we had the same amount of water, we had the same amount of sugar, we had even the same type of sugar. We had blocks of sugars for both. No, we had granules of sugar for all 3 cups. We made sure we put 3 teaspoons of sugar for each cup. Okay, cool. Now we ask the next question. What could improve the accuracy of your experiment? And this is one thing that we could have done to improve the accuracy of our experiments. Let's say we did not use a thermometer in this one. So if you did not use a thermometer, then you can say, okay, measuring the water temperature with the thermometer would also make results more accurate, because if you had measured, then you know exactly the temperature in which each cup the water was, which would make the results more accurate, because you know this was 100 degrees Celsius and this was 40 degrees Celsius and this was -1 degree Celsius. So it was accurate. Like this was cold, this was hot and boiling, and this was very, very like freezing cold. So then you ask yourself, were there any sources of error during your experiment? And let's say we had a little error in this one. Let's just say that you will say that the error could be in like the stirring speed. You know, it might have not been perfectly equal. You know, you are stirring, you can't always be sure if you're stirring at the same speed exactly as you did the previous cup. That's normal. Human error is normal. So what would you change next time to improve, to make sure there's no more errors? And then you could have said that next time we would use the same number of stirrers or a mechanical stirrer. A mechanical stirrer would, you know which speed you set it on, so you can have the same speed for all the cups. Or if you're going to stir yourself, you then can be like, okay, I'm going to do 5 stirs or 10 stirs for each cup. So 10, 10, 10. So that you know, okay, this cannot, you're removing that as a source of error. So that's how you evaluate your experiment once you're done. And also your evaluation is also supposed to be part of your conclusion. So once you're done with your experiment, I think I should have put this before the conclusion, honestly speaking. So you evaluate that, and then based on that, then you can like firmly say, you know what, this is the conclusion, is that when the water is hot, the sugar will dissolve more. Or if you find any discrepancy, you can say that this is what I see based on the results, but there were these areas of inaccuracy and could be a source of errors, and you know they may have impacted the results a little bit. You know, that's always good to also put in your conclusion. Now we're going to be looking at how to represent your data when doing experiments. So our experiment was just an example of many other experiments you could conduct, or you might conduct during your year in grade 10. And this is some of the things that it's important for you to know how to represent your data. You might be asked to draw a table, to draw a graph, all of that stuff. So I'm just gonna give you a breakdown on what are the rules to consider when doing or drawing these graphs, tables, or writing your data down. So first up, how to draw your scientific table. So this is an example of your scientific table that we have there that you could have used for the experiments that we just did right now. So making sure you draw your table using a ruler. It has to be neat, no broken lines, boxes must be nice and neat. You have to make sure you have headings on the top of each column, and you must make sure also in your headings that you use the units. So your units must be in the headings and not in the cells. So you can see the example here. It must be length, and you have the units you're going to be using to measure length, centimeter, and not in your cell write 10 centimeter. As you can see at the table, instead of it having 80 degrees Celsius, it's just 80, and we can see that the unit is in the heading over there. So your data must be recorded clearly and neat. make sure your writing is clean and neat, and you must make sure that in the first column you have your independent variable, and in the second column you have your dependent variable, which is not what we have in this example. Okay, we don't know what we're doing here. And then you have to keep your formatting consistent. No mixing of units. You can't have, oh, now your 5 is in milliliter, but your table is saying that it is 5 minutes, but it's actually 5 seconds. We don't know that. You have putting this in, you're mixing things up, and you shouldn't be doing that. And then the next way to represent your data, it could be a scientific graph. Here we have an example of a graph. This is a linear graph, but this is just general rules in terms of writing a graph. A graph must take up most of your page. So when you're writing an exam and you're supposed to draw a graph, don't draw a tiny graph. You have to draw a big graph. It has to take most of the page, maybe half of the page. And you have to label your x-axis, that would be your independent variable. And then you have to label your y-axis, which will be your dependent variable. And then include units on your axis as well. Make sure you have your units. And then include units. Give the graph a title. And make sure your points must be plotted accurately. Like, you're not just randomly putting the dots anyway. Like, if a person is counting and is reading, they're like, oh, it is 120. It makes sense. So you're plotting them accurately. If it's a line graph, jot points using straight lines or smooth curves. Your line must be nice and clean, not like a sketch. If it's a bar graph, bars must have equal width and also be equally spaced. If you're doing a bar graph. Now let's look at how you draw a pie chart. So a pie chart needs to be a circle, and it has to be divided into sectors. There's no other way you can do the pie charts without doing that. And you either can represent your data with a percentage or using angles. So, but they all have to total, like the whole sections that you make, it's either they have to total 100% or total 360 degrees, because that's the angle of a circle. So how to maybe calculate your categories in angles. So what you will do is you will have the category value. So let's say you have 15 students that are studying maths, and the total number of people in the class is, let me try and calculate this as I'm speaking. Wait. So let's say we have 15 students studying maths, and the total people in the class or in that grade, maybe we have 200 students. So we're going to say 15 math students divided by 200 in total, all the students in the grade, 200, and then you multiply that with 360, and your answer will be 27. So that will be 27 degrees will measure the amount of students in the pie chart. So you label each section or each category clearly. You have the name. It's either going to be like maths, and you have your units in the section, or you can have a key like the examples we have here. Each of them have a color-coded key at the side, so that you can just only put the value and the units in the section. So you still have to put the units in the section. You have maybe a key on the side. And make sure your lines are neat, and you can only do the color coding and the shading if you were instructed to. So if in the exam paper they say create a key, color code, shade your categories, then you will do that and you do those things. If not, you put the name inside and you make sure everything is nice and neat. And you use your rulers and your pencils for lines and for your labeling. when you're putting the labels, like the mathematics, the science, and all of that, use a pen, please. And now let's move on to the next section. Now you're going to learn how to plot a nonlinear graph. A nonlinear graph, just like in the image, is a graph that is not straight. It's either a curve or something like that. So the first thing you do, we already learned how to create a graph, but we'll say those things again. Firstly, for a nonlinear graph, you have to plot your points accurately. Those are the ones you do first anyways. Make sure it's in the correct number. You plot them accurately, so when a person is reading your results, it makes sense. They see the amount correctly. And then you have to connect your points using a nice smooth curve, but there must be no sharp lines. It can't be like sharp. It has to be like a curve, and it has to be nice and neat. So you have to use a pencil when doing that. You label your points. Both on your axes, like meaning like you label your axes with units, so you can see like a number of this per day, and you have the number of bakers per day. So these ones don't really have units, so you can put your units on the side or next to your label, how we showed you on the first one. And then you have to have a title for your graph. On top, you must have a title which explains the relationship between your variables, and then you can put there like number of loaves per day versus the number of bakers per day. You can put that title for this graph, and then identify the trends. Is it increasing, decreasing, peaks? But that's for you to identify that when you're writing your results. Now, how we talked about a bar graph. So this is what a bar graph looks like. And when drawing a bar graph, you have to use a ruler for your bars, and you must make sure your bars are equal in width and are equally spaced out. So how thick they are, width, it has to be the same, and also the space between your bars has to be the same. And then you have your x-axis. You create a category there, that will be your independent variable, and your y will have your dependent and amounts and the measurements. And then include units on your y-axis, because normally on your x-axis it's just like for bar graphs, it's normally like the name of something, name of students, or the subjects that students are taking. So it's like math, this and this and this, and or the nicest fruits, as you can see here, apples, oranges. So there's no units for that, but there will be units for people or the time or all of that stuff. So give the graph a clear title. Here it says the nicest fruit. Guess the people voted which fruits are nice. And the bars do not touch, because this is not a histogram. This is a bar graph, and they do not touch. They have equally spaces in between them. And then now we're going to be looking at the rules that you have to follow when you're drawing diagrams. In life sciences, there's a lot of drawing. They ask you to draw a cell. They ask you to draw different stages of meiosis and mitosis. They ask you to draw an egg cell, a sperm cell. There's a lot of drawing happening here. Draw a mitochondria. There's a lot of drawing. So these are the rules, so that you make sure you get your 5 marks. If it's 5 marks, you get all of your 5 marks. So this is what you must have in the back of your mind before drawing. So make sure your drawing is large, like it's nice and big, it's clear, and it has to take at least half the page, so everything will be very visible, including your labeling. You must use a sharp pencil, no pen. You draw with a pencil. Smooth lines, single lines, no shading or sketching. It's not a sketch. Keep drawing simple and clean and not decorative. Don't start decorating, adding colors unless instructed by your exam paper or your teacher. Label using straight horizontal lines, using a ruler. So you try to make sure your labeling is nice and straight and it's horizontal. Labels must be printed. Don't write your labels in cursive. You guess this is a bad example of the picture, but make sure you're not writing in cursive, it's in print. All parts must be proportionally accurate. So if in your cell wall, your mitochondria can't be the biggest in your cell, can't be the biggest organelle in your cell, it doesn't make sense. You have to be accurate in your proportions, and your labels must be nice and clear to see. Make sure you're labeling accurately. You've got the line going straight to where it needs to be. So the diagram must be in 2D, not 3D, flat. You must have a heading or a title under your drawing. So you'll be writing here, drawing of a cell, or you can just write cell. Labels on the right hand side when possible. Honestly, you can put them wherever, but if possible, you can put them on the right hand side only. Avoid coloring, like I said, unless you are instructed to do so. No cross labeling lines, like you can't have the line that is pointing at the mitochondria crossing the line that is pointing the nucleus. No overlapping of lines. No, none of that, please. So that's gonna ensure that you get all the marks for your drawings. These are easy marks for your exams. Get you an A right like that. So that is it from today. So let's just do a recap of what we touched on today. We talked about the scientific method and what it is, which is a step-by-step way to investigate questions scientifically. And everything begins with your curiosity. It's either something you observed or a question that you have. Then you create your hypothesis, which is a testable prediction. You test your hypothesis by doing an experiment. You obviously have to plan your experiment from the apparatus to the method and make sure you carry it out fairly. You have to identify your variables. We talked about the independent variable, which is what is going to be changed, the dependent variable, which is what is going to be measured, and your controlled variable, which will stay the same in the entire experiment. You record your results in a table with headings and units, or you can record results in using graphs like a bar graph, pie chart, or a non-linear graph. And I showed you guys how you draw those and what rules are in place for each of those graphs or whatever you're using to represent your data. Make sure you analyze your data, explain the patterns and the trends in your results, and evaluate your experiment as well. See if you can identify any errors and areas of improvement, and then you get into your conclusion and state whether your hypothesis was either supported or rejected. So I hope everything was nice and clear for you guys and easy to understand as well. But we are done for today, and we have completed the scientific method, and I hope it was easy for you guys to understand. But if you have any more questions, make sure you leave that down in the comments. But before we end this video, just a little new house rules, guys. Please follow us on TikTok and on Instagram. This is our TikTok handle at lastminute_A before the A. And on Instagram it's at lastminute_A, all together, small letters. Please follow those channels because there's some exciting content that you're gonna find there that's gonna help secure your future in whatever career you want to do, actually mostly in the health environment. So please, that's where you're gonna find all your job opportunities, bursary opportunities, and like any internships that are open for entry level. So it's either you for high school students or for matriculates. So please follow these accounts because they will be very useful in making sure that you make the right and informed decision when it's time for you to leave school, and also to help you gain experience while you are in school or while you're studying and working towards your career. So make sure you follow these accounts because a lot of useful information is coming from both of those channels. But thank you so much, guys, for watching, and thank you so much for supporting me. And please make sure to hit that like button to show me that you're actually enjoying this content, and to show YouTube that hey, this channel is doing God's work. And make sure you subscribe and share this video to your classmates because everybody deserves to get that A. Okay, we all are working towards the same goal. So share this with your classmates because they're also in the same boat as you are. So subscribe and share and like and also leave a comment. I want to hear from you guys. But from today we are done, and I'll see you in our next video. Bye.